Awesome. So, hi everyone. Today we are going to discuss a couple of problems on arrays. Okay. So now you're able to see my OneNote, right? Yeah. Uh,
Yes.
okay. Such a you since it is your first session, I just want to give you the way we are organizing basically. So the expectation here is
Okay.
that expectation is like basically everyone who joins to this session they should know basic things like loops, conditions, recursion, stacks, and queues. So these are the very basic things, right? Like if you are practicing algorithms, right? Hash tables and all those things. Okay. And we also discuss time
Right.
complexity and space complexity for each problem. So these are the prime areas that I'm going to cover. Okay. Arrays, matrix 2ds, and string problems, linked list problems, trees, graphs, sorting algorithms, dynamic programming, and greedy and backtracking algorithms. These are the complex ones. So that's where I selected around 15 problems on each, around 10 to 15 problems on each concept. This is already, like I already explained all these things last year around when I started last year, and again I'm doing second time. So we have linked list problems and trees, graphs. Okay. So it is very helpful to iterate again
Okay.
and discuss these problems. Okay. So just 3 weeks ago
Okay.
we started arrays, and we covered a couple of problems in arrays. Now we are going to discuss these two problems. Here are the two problems we are discussing this week. Um, okay. Okay, you can see my screen here, right? So
Yes.
yeah, first one is this. Is, I think last week we discussed about this array shuffling and find any duplicate numbers and all. So now we are discussing these two problems: merge sorted arrays using separate array. Okay, how can we merge sorted, like basically given two sorted arrays, create a third array from the elements of both the elements of both the arrays in sorted order. So here is the input. Example input is like this. So a equal to 1 2 3 4 1 3 4 5, and b is like this. Okay. 2 4 6 8 12 15, and output should be like this. So both a and b are sorted. The what we need to do is we need to create third array. We need to create third array, but that array also need to be sorted. See, look at this. We took the a from the first array, and 2 from the second array, and 3 from the first array. Basically, we need to make sure the entire list that you are preparing must be sorted. Okay. So a couple of folks join. Hey Modit, and hi Vasanta.
Yes, Suresh, as you
Hi. Hi Vasanta. Is it first time you joined, or did you join before?
No, sir. I am in first class, sir. I am in first class, sir.
Very good, very good. No problem. Welcome. Where are you from?
I am from Nalgonda, sir. I mean, currently I am staying in Uppal, sir.
Very good, very good. Are you is it like are you also from iFocus mission, or who introduced like uh how you get to know about this? So Tarun,
Sir, I am also iFocus member, Brigadier B22A,
very good, very good.
recently completed, sir. And I know this from Desu Brahma, sir.
Jesu Brahma, very nice, very nice. Yeah, I think he also joined last week. So yeah, basically I'm going
Yes, sir.
to
Yes, sir.
very good. So did you said you complete your BTech engineering?
Yeah, yes, sir. Yes, sir.
Very good, very good. Yeah, you just call me Suresh. So I am from Seattle. I live in Seattle. I'm from in Andhra only. So I work here in a healthcare company. So basically, I'm just helping with a couple of algorithms. So these are the topics I cover: array, strings, stacks, queues, linked list, and graphs, and sorting algorithms. These are very important in aspect in terms of preparing interviews, right? It's very very important concept that we need to prepare. Okay. So that's the main intention here. I think Desu Brahma also joined. Hi Brahma.
Sorry, sir. Good evening.
Yeah, no problem. Very good, very good. Welcome. So these are the two
Yes, sir.
problems
Thank
we
you,
are.
sir.
What is that? Yeah. So
Thank you, sir. Yes, sir. Thank you, sir.
no problem. Yeah. So these are the two problems
Yeah.
we are going to discuss this week. Basically, merge sorted arrays using separate array. That is the first problem, and merge sorted array is in place. So this is almost same problem. The second one is also same, but there is a there is a little bit complexity on that. So let's talk about the first one. So it's very simple array problem. There are two sorted arrays given, okay, and create the third array from these two elements. So anyone got a chance to practice this? I shared this problem 2 days ago. Um, so let's start with your ideas, like how can we solve
Hmm.
this problem, in an efficient way. So anyone have any
So,
idea?
like,
Yeah,
yeah, hi.
go ahead.
So we can take a third array, right? In this question,
Yes,
like one more array extra.
yes,
So we will take a array which is of length a plus b, like, and like we can take two variables I and j.
yeah,
Like I will be on a array and j will be on b array.
okay,
So so we will get the value of I, like a of I and a of sorry b of j, and like we will basically iterate both arrays and we will compare either which one of is smaller, and which one of is smaller we will put that in our third array,
very good.
and then accordingly whichever we put we will increment that only index. So I think that's one way we can do it.
Very good. That's very simple one. And yeah, this algorithm is very simple, and that's exactly the right algorithm. So anyone wants to have further discussion, like I will explain again what Modit said. Okay, I will use this one. So let's take the two arrays that Modit discussed. So A1345, right? So this is A 1, 3, 4, and 5. Okay, and what we have the other one 2, 4, 6, 8, 12, 15, and B here 2, 4, 6, 2, 4, 6. Can you guys see my whiteboard here?
Yes, Suresh.
Awesome. Is it updating quickly, or is it taking time while I'm writing? 2, 4, 6, 8, 12, 15.
It's perfect. No lag.
Very good. 8, 12, 15. So here is 8, 12, and 15. Okay, so now let's write down the indexes. Okay, I will choose another color. So this is 0, 1, 2, 3, and 0, 1, 2, 3, 4, 5. Right, so this is array B. Okay, this is B. So what he is saying is, Modit is said, like, we have two arrays and those two are sorted array, right? Those two are sorted. We need to build a third array. What we need to do is we need to take two simple pointers or indexes. Let's say we will take I and J. Okay, here is I and here is J. So, and what we need to do is we need to both set with zeros, right? That's the first index of this arrays. So now what we need to do is we need to compare the elements, the value of a of 0 and a of and b of a of I and b of j. This is b of j. So what is the value of a of 0 is 1 and b of 0 is 2, right? So what we need to take? We need to take the small one, right? So we will take the small one, whichever is the small. So a of 0 is small, then that is what we are going to put in the result array, which is, let's say, C, and we will put 1 there, and immediately we will increment I. Okay, now I becomes 1, but J is still 0. Okay, so now what we need to compare? We need to compare these two, A of 1 with B of 0. Okay, what is the B of 0? So basically, we'll compare these two, right? So then whatever is the small, whichever is the small, and we'll put that value there. Okay. Then we'll, since 2 is small, then immediately we will need to increment the j. So now j becomes 1, right? Now b of, sorry, this is b. Now what we do is we will compare a of 1 with b of 1. So now we need to compare these two. Okay. Somebody clapping, that's good, but I just want to make sure everybody understood. So any questions so far? It's very simple algorithm. What we are doing here is we are basically comparing each and every element of this, a with the other element of the b, and we are picking only the one which is smaller. Is that good? Tarun or Vasanta is, yeah, I just want to make sure you understood the algorithm. Let me know if you have any questions. Yeah, speak up. It's just a normal session. We all can speak, and let me know if any questions there. Brahma, is it clear? Or Tarun? Yeah,
Yeah, sir.
Yes,
It
Suresh.
is clear, sir.
very good. So, Satya, you also following, right?
Yeah, Suresh.
Yes, sir.
I'm following.
Good.
Yeah.
So here, let's talk about different use cases here. So it's very simple. Modit said, okay, we will compare and we'll take the first one. So I said sorted arrays, right? I never said this is incrementally sorted or decremental sorted. Like, it's not like is the inputs are given like this 1, 3, 4, 5, and all these things. But I'm just thinking, what about if the numbers are decreasing order? Okay, so let's talk about whether this algorithm works or not. So basically, what we do is you guys understood the algorithm, right? So basically, we will compare numbers and we will put the small numbers into the array here. So let's do how it work if the numbers are in decreasing order. If we are writing this algorithm, so what will happen? So that means a is like this. Numbers in a are like the same numbers. Let's put in decreasing order. Let's say 5, 4, 3, and 1. Okay. Now, and b 2, 4, 6, 8, 12, 15. So now it is like 15. Okay. 12, 8, 6, 4, 2. Right. Now if we follow the exact same algorithm, if we are picking the small one, what will happen to the c? Let's see. Now what you're going to do is, now you compare 5 and 15, right? You put whatever the small, you put the 5 here, right? Now you compare 4 and 15, right? What will happen? You put the 4 here, is that right? And then we'll compare,
Yes.
you will compare 4 and 3, you put the 3 here, and finally you put the 1 here. Now what you need to do, so you are putting in an increasing order, right? Now you can't put 15 there. If you put 15, that's not 15, 12. That's not in an order at all. So it's not in a decreasing order even, right? So because after 1 you are putting 15. So how can we solve this? So basically, if the input is in increasing order, put the elements in the increasing order. If the input is in a decreasing order, put the element in the decreasing order. So here what we need to do is, anyone can guess what we need to do here is the inputs are in a decreasing order, right? So in c, what we need to put the elements in the same decreasing order.
You put the elements which are bigger than previous.
Yeah, but how do you know? That's good. That's a very good, Tarun. That's a very good point. So what we need to do is, we should not the small ones. What Tarun said is, since the elements are in decreasing order, we also need to put the elements in the decreasing order. That means let's find the big one. Whatever the big one, let me take another color. So whatever the big one, don't put the small one, put the big one here, 15. And again, whatever the big one between 15 and 4, right? So of course 15 already increase, so you will increment the 15. And then what you do is you will compare, these two, 5 and 12. Again 12 is big, put the 12. Again you compare 5 and 8, you put the 8. And then you compare 5 and 6, you put the 6. Now 5 and 4, that's where you found, okay, 5 is bigger, put 4, put 5 there. And then 4 and 4, anything you can put, either of the 4 from A, that's fine. And then you put the 4. And now this 4, and no, this 4 is incremented, so this 3 and 4, again you put the 4. And then 3 and 2, you put the 3. And finally 1 and 2, you put the 2. And finally 1 comes here. So now it is correct. So what Tarun is saying, so we put the bigger numbers so that the result will also in a decreasing order. Okay. So now for this input you need to put in increasing, like you need to put the small numbers for this input. If you are considering this input, you need to put the big numbers. So how, they're very simple. I think we already arrived at the correct algorithm. So how to find out whether you need to put the small numbers or the big numbers? How to find out whether the input is decreasing order or increasing order? Anyone tell?
Compare first and last element of array.
Very good, very good. So can you explain, elaborate that explanation a little bit? How do you find Modit?
Yeah, so we will get first element of an array like zero index, and we will get the like a dot length. Suppose array name is a dot length minus one, and we will compare both. Like suppose we take a, so one we will compare one and five. So like one is less and five is greater. So we can see that zero index element is smaller and last index element is bigger. So it is in an increasing order.
Yes. So we'll compare, if a of 0 is less than a of 3. Let's compare just any numbers. It doesn't find, no need to compare these two. Or even if you can compare these first and last, that is also fine. So
Right.
um, this, that's good option. So this way, so if a of 0 is less than a of 3, that means this is small number, it is an increasing order, right? So you need to have a flag saying, okay, this is an increasing order. We will maintain one more flag, a string variable or something like a boolean variable, is it increasing or not? So then you maintain f equal to increasing, ins, something like that. Else f equal to decreasing, des, something like that. So just compare one, even better to compare both. Some, even if you want to really complicate the problem, I will give you one array increasing, one array decreasing. It is becoming complex now. So in the initial stage, if I say everything is increasing, very easy, just take the small ones. If every array is decreasing, take the big ones. But if one array is increasing order, one array is decreasing order, then how to tackle? So then you need to maintain two flags. You need to maintain what is the order of the A. Is it odd? A is increasing order or A is decreasing order? Or B is increasing way or in a decreasing way? What are the numbers? And then you need to figure out, then you need to ask the interviewer, okay, you gave the inputs, one is in decreasing, one is in increasing order. How do you want me to put the final array? Do you want me to put an increasing order or do you want me to put in decreasing order? Right? I'm just complicating the same problem, since this problem is simple problem. If you started with this problem in interview, you will simply, within 5 minutes, you already came with algorithm. Hey, take the two integers, just compare and put it there. Now the interviewer can increase the complexity, right? That's where this will enter into the discussions. Even though you solve the first one, I will ask these questions second. So the first variant is, you know I said increasing, now it's decreasing. Now in the third variant, I will complicate the problem further. One array is decreasing, one array is increasing. then how are you going to do that, right? Then immediately you need to ask, hey, what is the final array you want me to put? So the final array, do you want me to put it in increasing order, or do you want me to put it in decreasing order? Okay, let's say, okay, put it in increasing order. Okay, then what you do? So one array is increasing, one array is decreasing. Do you want me to write that example here? So how you going to compare and what you going to put there, this stuff to arrays here. Yeah, so basically, let's take the same elements here, right? So 1, 3, 4, 5, and the other is like reverse, 15, 12, 8, 6, 4, 2. We have, this is increasing order and this is decreasing order, right? So now in the final array is exactly the same way. We want 1 and then 2, 4, right? So how do you compare? So how are you going to put the elements? Share your ideas freely, share, no need to hesitate, um, you understood the problem, right? Basically one array is a increasing order and the other one is in decreasing order. Okay,
We can add the elements from last index onward.
you can add the elements from the last index for array B, right?
Yes.
But for array A, you need to add from the beginning only.
Beginning.
Basically, instead of comparing a of 0, b of 0, what you do is you compare a of 0 with b of n minus 1, or whatever the b length minus 1. You compare these two, right? It just simple analogies. You can think, the let's say take a school, and these are all boys, or let's say the students, boys and girls. They stood in increasing order of their height. And another class, this is one class, a is one class, b is another class. In this class they stood in a decreasing order of their heights. Now finally you need to put all the elements in an increasing order. What you do, you will take the first person here and you will take the last person here, compare their heights, right? And whoever is the shortest, then you put in the final array. It just defines where you start. That's it, right? Very simple. The one is like increasing, another one is decreasing. You need to find where to start. So if the output says put it in increasing order, you start from the first of the array A and last of the array B. But if the input, I want the output in a decreasing order, I want 15, 12, something like that, what you do, you start with the last element of A and the first element of B. Correct? You understood? You need to compare these two, 5 here and 15 here. You need to put the 15, the biggest. You want in a decreasing order. You just change the place where you start. Are you guys clear, or any questions?
It's
Am I
clear.
am I confusing you? Maybe if I'm telling more and more variants, and if I complicate the problem, it will confuse the people. So just want to make sure you guys are following. So give a thumbs up or something like that, so that I know that you guys are following. Yeah. So I'm happy to explain. If not, awesome. I got some thumbs up, one thumbs up from someone. Very nice. That's good. Good to know that. So let's jump into the algorithm. Actually, in a real world, basically we use it to discuss like this, and we will give 10-15 minutes basically to write the algorithm. So I don't know whether we can still try that. I never tried that option. Basically, once I explain the algorithm, I'm going to show the code. Anyone want to try? Let's say for the simple case, just both are in an increasing order. Anyone want to write those few lines of code, and you know you can paste it in the comments.
Like I have one doubt, like one approach, one more
Sure,
approach.
sure.
So like, can we do it like this? Like we have two arrays, A and B, and our third array, final array.
Yeah,
So we can copy all the elements from A, copy it in B, C, sorry,
yeah.
and then copy all the elements from B array to C, and then we can like put some like we can sort that array like as per
Very,
the requirement of the question.
very good, very good. That's very good approach. I think we forgot to discuss that. That's a very simple approach in terms of doing it, because you don't need to compare each and element. You are just putting all the elements and you're
Right.
starting, right? So we need to think about the complexity of it. So very good question. Let's start fresh again. I think the board is really big. I'm going to clear it and write it. So we will compare the complexity of that algorithm what you said with this algorithm what we just um, tried. Okay, so here is the first array. So what Modit was saying is, why we need to do all these crappy comparisons? Why can't we put everything in one basket? Like, right, 1 3 4 5, 1 3 4 5, and 2 4 6, 2 4 6, 8 12 15, 8 12 15. Okay, so what you're doing is you can put everything in this final array. So you can take the length of, what is the length of this one, 4, and what is the length of this one, 6, right? And you take the 10 elements here, 10 spaces. So now you put all the elements and then sort it. There are a lot of sorting algorithms. You can do it. It's simply, hey, put all the, like, loop array A and loop array B. Basically, loop in the sense you need to traverse all the elements, and you can put it here. And then let's see, 1 3 4 5, and then you put the elements from the B, 2 4 6 8 12 and 15. Okay, now it's not in a required order, you can just sort it. Okay, then what is the complexity? Okay, so now it's a order of, this is n elements and this is m elements. Okay, so in order to put all the elements into this, you already order of n plus m. Basically, you are navigating all the elements of this, all the elements of this. Let's say the final length of the array is n plus m equal to let's say l. Okay, this is the length of the final array. So now in order to sort it, what are the sorting, like the great complexity of sorting algorithm? Anyone know? Like if you do quick sort or merge sort or any other sorts, right? I think if I remember correctly, at least, let's say this, it's n log n. You can't do better than this, right? So basically you need to iterate all the elements, you need to compare, and again you need to shuffle the elements of this array. So you're already navigating one time all the elements of A and all the elements of B, and then you're putting here on top of that, you need to do processing of the array. You're sorting the array, right? So,
Yes.
but if you look the other algorithm which we just completed, are we taking any extra time to sort it? It is just order of, what is the complexity of that algorithm we just discussed? What is the the complexity of the algorithm we just discussed before?
So like we are only traversing both the arrays, so like and doing some constant work.
Yeah, n and m. Let's say the length of A is n and length of B is n. Then what is the complexity? It will be order of n plus m, right?
And plus
Yeah, because you're just navigating one time and you're deciding which one you want to put. Basically we are using the input. Basically the input is clearly says array is already sorted. If array is already sorted, what is the point of putting everything here and shuffling? It's a navy solution, very, but it's not useful, right? The We are not using the the fact that these are already sorted. This is sorted. This is sorted, right? So then we can, in a linear time, without again sorting the entire array, we can decide which element you want to put. That is the main purpose of this algorithm, right? Basically, we are not doing the actual sort. We are, since the array is already sorted. If the array is not sorted, let's say the A is not sorted and B is not sorted, then it's really tough. Either you need to sort A and B first and then do the same algorithm, or as Modit said, put everything in this array and then sort the final algorithm, final array. Both are same. I don't think that will give any advantage. Like, you can sort A and B and then you can execute the same algorithm, or you can put everything in the final array and you can execute the sorting algorithm, right? But here the input clearly says the input are A and B, the two arrays already sorted. That means we need to come up with a better solution which doesn't require sorting of the final array. Is it clear to everyone why we did not choose that particular approach, the sort, putting everything in one basket and then doing the sorting? That's not what we chose. Is it clear? Satya,
Yes.
Brahma, yeah. Vasanta, is it clear to you, like, the two approaches what we discussed?
Yes, sir.
Cool, cool, very good. Okay, so are you guys ready to write the algorithm? It's
Yes, sir.
very good, very good. It's very basic array algorithm. So we need to consider other use cases here. So let's take that just a simple approach, simple input. Both arrays are increasingly sorted, and we are putting in the final array based on the values, right? If the value 1 and 2, which is smaller, we are putting, and then 2 here and then 3 here, we'll compare these two and put the 2. We'll compare these two and put the 3. So we'll do that simple algorithm. Now what you do after A is over, let's see, you put 3 there, 1 2 3, and then 4 here, and you compare these 4 and another 4 here, and then you compare 5 and 6, you put 5, and then A is over, right? You put 1 here, 2 1 here, 3 4 5. Now A completed, right? That is, then what you need to do, so what we need to do after 5, there is no comparison anymore, right? Yeah, go ahead, Vasanta.
Yes, sir.
Yeah, what we can do now, we can simply, so after 5 is over, so we can simply copy the elements from B into the final array, right? Because these are already sorted. You can simply put 6 there, 8 there, 12 there, and 15 there. That's it. No need to compare anything because A is already done. Like, let's say this small class with 4 people and this another class with 6 people. You already compared 4. All those 4 people already lined up. You simply copy the rest of the elements. So here is the trick. So we don't know which one is smaller, which one is bigger, right? So now in this input, A is smaller. In this, so B is bigger. So it could be, both could be same length, or A could be the longer, bigger than B. You know, so we need to be very careful while writing algorithm. Okay, it's not like same length. They never said A and B are same length, right? So A length is n here, and B array length is m. So we don't know and which one is bigger, which one is smaller. So how do you, that is also very important to cover in the algorithm. Okay, so have you, anyone tried writing the algorithm, or let me know if you want me to share the algorithm. I will start sharing the algorithm. Modit, are you trying? Anyone want to try? Just write those loops if you can. Otherwise, I'm going to open the actual program. Where is that? Array tuples, array union. Is it not written or somewhere? It will be somewhere. I think it is. It is here in my. So I'm maintaining all the algorithms here in online GDB website. So we covered these four, and here is the one we are discussing today. Oh, here it's already open there. I can show the algorithm. So Modi, should I share the algorithm or anyone want to try before writing, before showing the code?
Like I'm still writing, so like you can share also. Like
Okay, so yeah, in order to save the time, like I'm showing the algorithm, we will discuss the second one as well. Okay, so basically I hope everybody understood the algorithm, what we are doing and what are the different use cases. I just said one use case, right? One use case is A is smaller, B is bigger, A and B are same length, that is second use case. And the next use case is, you know B is empty. B is just no elements in B. A has elements, or other way around. A has zero elements, B has some elements, and finally another one is B. A and B both are empties. So our algorithm, when you're writing an algorithm, you need to make sure it works for almost all the inputs. Okay, so here is algorithm here. Merge sorted arrays. Um, as I said, I just took the same. Here is 1 3. I think this is the first input that we discussed. This is another input where A is bigger than B, and see that input with zero values in the second array. This is another input, right? This A and B, A has elements, B doesn't have any elements. Input where arrays of two different sorted values. So basically, input where arrays of two different sorted values. So 1 2 4 5 and 6 7 8 9. Basically there is no common value here. If you look at the first input, there is a common value, right? Can you guys see my screen? Is it okay, or the zoom level is fine?
It's okay, Suresh.
Yeah,
It's visible.
awesome, awesome. So now, very good. So what are we doing here? Merge array.
If
Just
both the algorithms contain same elements,
what is that?
if both the arrays contains same elements,
If that's very good option, yeah, we need to tackle that input as well. If both arrays have same inputs, the final array is also same. We are not reducing the number of elements, right? If you look at the output here, right? Let's look at the output here. So we can see both 4 and 4. So we are not in, it's not intersection or anything. There is another problem where you do the union intersection, you eliminate the duplicates, lot of crazy things you can do. But this is not something we are doing. Let's say two people have exact same height. Do you say one of the guy go home? No, right? Those are same height. The you know two students, they just sit or stand side by side, right? That's what it is. 1 2 3 4, and again 4 5 6. So it's duplicated. So what you're saying is input where every element is duplicated. Very good. That is also another use case. Input where arrays of two different sorted values. It's not like that. Input in which all elements same in both the arrays. Okay, so that means let's take like something like this, like 5 5 and 5, and then let's say here also we have 5 5. How many 5s we will get? How many 5s we will get in the result? You can type or speak up, anything is fine. If you are keep typing in the comments, that is also fine, so that I know you guys are following.
8
How many?
6 6.
Very good. Yeah, 6, 4 from this array and 2 from this array. So yeah, so let's look at the main algorithm. So here is a merge arrays. So what are we doing? We are just simply sending A and B, and finally we will get the input, like the output merged array, and we are printing the merged array. Okay. So what is the algorithm? Very simple, as we discussed. I am calling n1 and n2. N1 is a dot length, n2 is b dot length, and now result. As you know, in order to find the result, how many elements we going to take? Just n1 plus n2, right? So we are taking third array, which is result 1, by having n1 plus n2. We need to have n1 plus n2 elements in this result, right? As Modit said, we just took simply three uh, in pointers: I equal to 0, j equal to 0, and k equal to 0. So we use I for array A, j for array B, and finally k for array result, because you need to know where you need to put, right? So here is a while loop. So it's not like for loop, because while loop for you can use for loop, but the problem here is we don't know whether both arrays have same length, right? That's why while loop is better. So until I less than n1 and until j less than n2, that means both are, like, you're navigating I and j, make sure they are less than the length of the arrays. Nice, Modit already shared the algorithm. Very nice. Yeah, we will also like practice that sharing algorithms, and we can give some time to write. We can also do that, but the problem is, if we are waiting for other people to write the algorithm, it will be like we can discuss only one algorithm, maybe in one day, right, in one lesson, one session. So
Right.
very good, very good. I'm just looking the algorithm shared by Modit here. I is less than a dot length, b is less than. Very good, very good. um, Z equal to z plus plus. Okay, you are putting c of z equal to b of. Okay, is that in the increasing, is it in a decreasing order? You wrote oh, no, 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 you
So
you
like
you take the
it's in
small one. Okay,
increasing order.
got it, got it. But where is that
Yeah.
a of I? You are not taking a of I at all. In the else case, you need to put the a of I, right?
Yeah, actually I mistakenly put
B of.
both place B
Yeah,
of
yeah, yeah. So
J
that should
on.
be a of I, and also you forget to increment the counter. Whenever you take the element, you need to increment that counter. Yeah, but anyway,
Right,
very
right.
good.
So I and J will also be incremented. Yeah.
Exactly, only in the inside the if condition you need to do that. Anyway, that's good attempt, very good. So this is exactly what the algorithm I wrote here. Okay, let's coming back to our algorithm here. So so here, check if the current element of first array is smaller than the current element of second array. If yes, store the first array element and increment the first index. Otherwise, do the reverse. Basically, increment the second array. So basically, same thing. If a of I is less than b of j, that means the element in I is a. The element in the array a is smaller. So we are simply saying result k plus plus equal to a of I plus plus. You know these conditions, right? That the k plus plus, basically it will take the k value and put the values a of I into a of k, and immediately increment the k, and also immediately increment the I. So it's a C sharp. I usually write in C sharp. You guys can write in any other language. It's just simply like this. If you guys want to make it simple, so what I'm doing here is, instead of writing like this, maybe I can write in a two lines. So a of I, f k, result of k equal to a of I, and immediately, since you take the ith element, you need to increment I plus plus. You know these conditions are I equal to I plus 1. Basically, I plus plus equal to I means I equal to I plus 1. Okay, and at the same time k equal to k plus 1. You need to increment k. The same thing here I'm doing. Okay, there is no difference. It's a simple one line statement, but if you are confusing, if it is confusing to you, I can write in separate statements. K equal to k plus 1, j equal to j plus 1, because in this else case b is smaller, right? If it is not satisfying the if case, it will go to else case and it comes here. You guys can answer what happens if both are equal. Both are equal, what will happen in this scenario? From which array it is taking? Anyone can guess? If a of I, like 4 4 in the input, we have 4 and 4, right? So which array the 4 will be copied first? Are you guys following us so far or no? You can type in the chat as well. Yeah, Tarun. Anyone? Vasanta, are you following? Any questions so far? Any? So my question here is, if both are same, from which array it will copy the element first?
So it will go to else case, I think.
Yes. I'm not sure whether you guys are following. Yeah, Modit is following for sure. Vasanta, are you following? Tarun?
Yes, sir, I'm following, but screen is little slow, sir. That's why I'm confusing.
Oh, I see. I see. Okay, now can you see the changes I made? Basically, I am having if condition here, right? A of if a of I is less than
Yes, sir.
b of j, if the element in A is smaller, I am taking the element from A. Else, I am taking element from B. That means even if both elements are same, it will take the element from B. Then do you think the element from A will be lost? No, because we are not incrementing I. So it will be compared next time with another element of the B, right? Very good. Modit already updated the code. Very good. So this is now what will happen is in this for loop we completed adding the elements and doing all these things. So now what will happen is, so I will just if you guys want, I will keep it. I will remove this code if it makes easy to understand, because putting everything in one line may be confusing. So this is if case and this is else case. Okay. Yeah. Now what will happen is, this while loop will end if any of these conditions satisfied or are not satisfied. Basically, if I equal to n1 or j equal to n2, that means when you reach end of any of the array, if the a is completed, the while loop will end. Or if b is completed, let's say b is smaller than a, if b completed, if j reached n2, then it's immediately exit the loop. But the problem here is there could be extra elements in another array, right? We don't know which array is left over. So basically store the remaining elements of array, if any there. Like if I is still less than n1, let's copy all the elements of I into result. If j is still less than n2, let's copy all the elements of b into result. So here one of these conditions will become true if the arrays are different in the size. If the arrays are same, let's say the a and b are exactly the same size, then in that situation I and j becomes equal to n1 and n2 at the same time. It's not a problem, right? No, there is a, yeah. So that's why this basically copies the remaining elements, whatever the elements left over into the final array, and finally we are returning the result array. Okay, it's just like this, just like what we discussed, right? After 4, after this, right? After 5, from a is completed, So you took 1, 2, 3, 4, 4, 5. Now A is completed, but there are elements from the B, right? We need to copy 6, you need to copy this 8, you need to copy this 12 and 15. That will be done in the other while loop, this while loop. Is it clear, everyone? Or am I confusing you? Just put some in. If it is clear, just type OK in the comments so that, or yes in the comments, or
It's
give a
clear,
thumbs
sir.
up. Yeah, or give a thumbs up. Great. It is very simple algorithm, but while writing the code, it will take time, because if you are, just imagine you are on the whiteboard, there is no hint, and you need to come up with all these ideas what will happen if extra elements left over. So when you are if you are if you took only the same length, then you never thought of that, right? So here is the problem. So you need to think about all the input cases, and we need to write the algorithm. So let's run the algorithm and see. Something I did some mistake somewhere. What is happening? Oh, maybe I forgot the while loop. Yeah, it's not in a beautify. Let's try beautify. Yep, now it is beautified. Okay, so yeah, so now let's run again. Okay, look at this. So here is the input array A, 1, 3, 4, 5, and 2, 4, 6, the same elements, and the measured array is the same order, 1, 3, 4, 5, and all this, right? So pretty cool. So it is in a correct order, right? So now let's try with other input. Make sure our algorithm works for every input. Okay. So we tried with this input. We can try with another input. So while you're writing algorithm in the interview, also you need to run your code with different inputs. So here, what is the difference here? Here the number of elements in A is more than number of elements in B. See, it is also the same. But if you forget to write these two while loops, what will happen? You can try it out. Like if you want to try, let's say you just wrote only one while loop. Let's see what happens. You did not think about these two cases. If I run, what will happen? See this. You are getting zeros after 5. So that means 0 is the default values, right? So zeros are the default values, but you lose a rest of the elements. You lost the elements like 8, 12, 15. There is no 6. Only 2 and 4 copied. 2 is there, and both the 4s are there. Once you completed one of the array, once you're done with B, you are thinking you are done, right? So that is the problem. So these two while loops are helping you to copy the remaining elements from wherever available. If there are some elements available in A, they will be copied. If the elements are available in B, they will be copied. Okay, we can try with 0 as well, the 0 elements in the B. So now the array B has no elements. So simple, 1, 2, 1, 3, 4, 5. We are just taking, but basically what will happen in this, with this problem, with there is no elements in B, what will happen? Simply the while loop here will be exited, because n2 is 0. N2 is 0, and you starting J with 0. So 0 is less than 0. No, 0 is not less than 0. So there is nothing to compare. Simply it will come here and it will copy the elements of A into result array. Simple, right? So if you guys want to debug, what you can do is you can take the code and put it in your where and convert into whatever the language you want, JavaScript or whatever, and then try to debug how the code is executing. So once you know how the code is going, then it will be easy to write further algorithms. Okay. It's very easy. We are done with this. Let's see if we have any other inputs here. Yeah. Now, inputs were arrays of different values. Of course, there is no common value. Make sure it works for this is the best case here. Common value. There is no common values, and the length is also same. 2 4 5 4 6 7 8 9. So cool. It will work. And this is the one I think Tarun said, right? Let's see what happens if we have all the elements are same. We are expecting 5 6 5s. Yeah, 5 5 5 and 5 5 5. Simple. It's working, right? So now this is the algorithm for merging of two sorted arrays into a third array. Okay. Now let's go to the next one. So is it clear to everybody? Any questions, or if no questions, we will jump into the next algorithm, which is also variation of the same algorithm. Give some thumbs up, or let me know. Great. I think Harshad, you just joined, right? So yeah, I think Tarun can explain you, or I will share the code. Basically what we are doing is basically we are merging two sorted arrays. This is the algorithm we just discussed. Okay. So I can show the algorithm, um, the statement of the algorithm. Basically, there are two sorted arrays. Create the third array from the elements of both arrays in a sorted order. That is the one we just discussed. Okay, so both the arrays are already sorted.
Okay.
You just need to create the
Mm-hmm.
third array, which is also sorted. Okay. Now, little bit variation here
Mm-hmm.
is
Yeah.
awesome. So now we are discussing the question number 6. Merge sorted arrays in place. This is the main algorithm that we get in the interviews. Basically, this is very simple. You are taking one extra array and putting the elements. Now people will say, hey, don't use extra memory. So before going to the second algorithm, let's discuss about the time complexity we already discussed. And now order of n plus m, and is the length of a, and m is the length of b. Order of n plus m is the time. What about space complexity? Yes, C. Space complexity. Anyone can guess? Time complexity. This is TC, and space complexity. What is the space complexity of this algorithm? How much extra space we are taking?
Order of m plus n. Right.
Exactly. It's also the same thing. We are taking n plus m. So if we have 5 and 5, we are taking 10 elements, right? So now what we are going to do is, by doing in place, basically given two sorted arrays in the next algorithm, we are trying to do without taking extra array. So basically two given sorted arrays a and b. Array a has unlimited memory, or enough memory to hold the elements of the b. Basically this is already given. A is bigger than b. You can put all the elements of b into the a for sure. Just imagine there is a very big class a. Okay, and just only few elements in that class, few students, but we are pretty sure that a is bigger class. The room a is really big, where you can definitely put the students of class b. That is already given. Okay, now the current number of elements in a are also given as an input. We are giving that because if the a is big, I know, but is it full? If it is full, you can't put the other students, right? So we are giving one more input. We are giving two classes a and b. The a class have these many students and b class have these many students. We are also giving, you know uh, how many elements in the class a. Okay, if the class A is already full, you can't put B, but we are pretty sure that you can definitely put the elements of B into A. That's what we are giving. So sort the elements of A and B without using third array. This is the main thing what we want to do. Basically, don't use the third array because we are pretty sure A is bigger. Can we use A as a temporary storage? Like how can we do that? That is the in place algorithm. So there are multiple inputs here. The input is that the both arrays already sorted, and also another one is number of number of elements in A equal to 4. Here is a 4, right? 1, 2, 1, 2, 4, 5. Okay, but here there is a lot of place here. What we are saying is there is a enough place where you can put the elements of B into here. But is it something we are just putting at the end? If you are just putting at the end, it's not the correct output, right? Let's say if you are putting at the end, what will happen? A is already like this. A is 1, 3, 4, 5. And if you are putting at the end 1, comma 3, comma 4, comma 5, and we are putting 2, 4, 6, 8, 12, and 15. You can just simply copy the elements from here to here, okay? But that's not in a sorting order, right? This is not in a sorting order. So finally, we need to put the elements in the sorting order. So what are the different ways to do this? Let's talk about different approaches. How can we do this? Anyone have any ideas how to do this in place? The Navy approach, um, as I think Modit said, simply put everything in one basket. Put everything, since we know this basket is big, we know it can hold the elements. You can put everything there, just like I put here, right? You just put all the elements here and then just sort it, right? So you can put all the elements 1, 3, 4, 5. So this is the elements of A, right? And then you put the elements of B, 2, 4, 6, 8, 12, and 15, and then sort it. That's simplest solution, right? But is it an efficient solution? Anyone want to share any thoughts how to do this in an efficient way? If we do this, what is the complexity? Yeah, just feel free to answer, because if you are interacting, then it will be interesting for me also to share. So share your ideas, it's just a interaction class. Anyone? Satya, do you want to share anything like how to solve this problem, or are you following so far?
Yes, Suresh.
Yeah. So how can we solve this? So if you sort it, right, so what is the complexity of this one? Right now you are putting everything in one basket, right?
Yeah.
That itself takes order of
Every element you need to check with all.
every element.
Here it's time. Yeah, every element you need to check with all elements. So that is the like it will take time.
Yeah, definitely. Order of analog n is the, I think this is the uh, best sorting algorithm. Like you can't do better than that,
Yeah.
right? Order of n square is definitely
Right.
here, but you can do order of n log n in order to sort the elements. You can take quick sort or any other sort. That's best, I think. So is it really required to do that? So we need to think about that, right? Putting everything in one basket
Hmm.
and then we can do. But how do you do if you are in a, just imagine you are, this is all the classrooms and these are the students of different height. So what you do to put all them in a correct order?
So like there is one way. So like
Yeah.
suppose like A and B. So like we will like traverse B array.
Mm-hmm.
Like suppose two first element is two, and then we will compare like right find its right position in A array, and then put it there, and
Mm-hmm.
then we have to like shift all the other elements to like in right direction as well.
Very good. Mm-hmm.
I think.
Very good.
Uh,
That's,
but
yeah.
but like shifting all the elements like in one direction will also be like time consuming. Like
Exactly. That is the problem in that algorithm. So I think very good algorithm Modi shared. Let me explain what he shared. So this is what you're saying, right, Modit? So A is unlimited. Let's say A memory is unlimited, but now B has some elements, right? So what are the elements of A? 1, 3, 4, 5. Just only 4 elements we have. 1, 3. Oopsie. Let me write it clearly. So 1, 3, 4, 5. And what are the elements of B? 2, 4, 6, 12, 15, 8. 12, 8, 12, 15, right? 2, 4, 6, 8, 12, 15. So Modit, what you're saying is basically, this is sorted and this is sorted. Now you said you're going to take an element from B, right? And you're trying to
Yeah,
see where
yeah,
to put it, right?
yes,
So very good. That's very good algorithm. So now one is right. You need to put the two between these two elements, right? That means you need to put the two here, and you need to shuffle all the elements, right?
right, right.
That is the problem. So it takes time. Again, it's not order of n plus m anymore, because just for two you are iterating all these elements. Again, you get four, right? We can do that. Let's figure out. Let's say you followed that algorithm. What will happen is, okay, you found the spot here. Two, I think you need to, okay, 3, 4, 5, right? You just shuffle the elements. Is that 3, 4, 5? Yeah, 3, 4, 5. You shuffle the elements. Now 2 is done. Now what you do? You take this 4 and you find the element. What is the position of the 4? What is the position of the 4? You need to put here, right? After 3, basically. Correct? Now what you need to do?
Yeah,
Again we need to shuffle the elements. You need
shift. Yeah,
you need to shuffle 5 into here and 4 into here. So 5 comes here and then 4 comes up. Sorry, you need to erase this. This 4 comes into here. Now this 4 can move from here to here. Very good. This way, by the time you complete all the elements of B, they will be inserted into the A at the correct location. Finally, you will be done with the algorithm. Now let's talk about the complexity of this algorithm. So this is n elements and this has m elements. Definitely you are navigating each element of B only once. You are not iterating multiple times of B. Pretty sure order of something plus m for sure, because you are just taking one element and find what is the best spot. You're taking one element and finding the best spot. But what about the complexity of A? You are shuffling all the elements. Basically, for every element, you know, you are shuffling rest of the elements. So let's say that means it could be, let's say in the
like
worst
in the
case,
worst case, it
in the
can
worst case,
be
you are
n or n minus 1.
no, I think in the worst case, for every element of M, you are shuffling all the elements of N. So it will be like NM, N into M, right? Let's say the elements of B are smaller than all the elements of A. So you need to put the element at the beginning, and you need to shuffle rest of the elements. Every time you need to shuffle n elements. That's a worst case, right? So it is very, like, it's not efficient. You think that what is the need to shuffle? Like it's like you can do this, but there is a issue here, right? Are you guys following so far?
Yes,
I think Modit shared very good algorithm. This will work, no problem. But for every student, you are shuffling all the students. You are taking just a simple example. Just think of this as two classes, and the classroom has students with different heights. So our ultimate goal is to put everyone into the array A in the increasing order. Okay. Now what you're doing is you are taking each element from the B and trying to insert correct location. And in order to insert, the problem with arrays is